Hi, guys. All right. I'm going to take a cue from Lori's talk and get a selfie because Pixar didn't happen, right? Cool. All right, so I'm going to talk to you a little bit about ES6 in practice. But first, a little bit about me. So I am first and foremost a father, a stepfather, and a husband. I run Santa Barbara JavaScript, which is our local meetup up in Santa Barbara. As Sonia mentioned, I'm an avid scuba diver, an underwater photographer, and I'm president of Paradise Dive Club. I've been building and shipping software professionally for a little over 2 decades now, and I'm currently staff engineer at Procore Technologies, building the software that builds the world. It is, I can say, hands down, the best job I've ever had. We're always looking for good people, so see me in the hallway if you're interested. We'll talk more. All right, so enough about me. Before we dig into ES6, before we find out what this is all about, let's take a moment for a brief history of the language. So in the beginning, there was Mocha. And it was released, and they called it LiveScript. But the marketing gods had to be appeased, and recruiters weren't confused enough already, so they renamed it JavaScript. And they saw that it was good, so they standardized it. But JavaScript was a registered trademark of Netscape Corporation. So how about WebScript, or maybe BrowserScript, or Brendan Eich's site Scheme as one of the major influences on the language? Well, maybe instead let's call it something really nasty. Sounds like ECMA. And what we ended up with was ECMAScript. ECMA, for those who don't know, is the European Computer Manufacturers Association. They're the standardizing body that manages ECMAScript. So we got ECMAScript 1, and then we got version 2, and then we got version 3, and then we got version 4. Well, actually, version 4 didn't happen. The committee, the TC39 committee, split into warring factions and couldn't agree on what should be in ES4. But they eventually extended an olive branch and came up with a compromise that ended up being version 5. And then we got version 2015. Wait, what? The actual name of the language is ECMA 262, 6th edition, ECMAScript 2015. It rolls right off the tongue. Regardless of what it's called, it made a big splash. And people were really excited about this new spec. But why did I care? Well, I've been using JavaScript since it first came out in 1995. And I've been following the spec for a while and was really interested in getting in on this new hotness. So I figured, like most things, the best way to learn it was to teach. So I went back to my JavaScript meetup and gave a 3-part series of in-depth talks and hands-on coding exercises to learn ES6. And then, with a head full of knowledge, I got the bright idea to introduce ES6 to the enterprise. Nope, not that enterprise, this kind of enterprise. And those of you who have worked in an enterprise software company know that we often do things by committee. And in the case of my last employer, this meant the Enterprise Software Architecture Committee, comprised mostly of former and current back-end developers whose default stance is JavaScript sucks. So needless to say, they were dubious, and they asked me lots of questions like, can't we just wait until the spec's fully implemented? And I was like, well, we could, but this is not like the rollout of ES5. For one thing, browsers are evergreen now, and we have amazing tools like Babel that will let us use the features of tomorrow today. But there was still a lot of fear, uncertainty, and doubt. So I waited. And I evangelized every moment I could. And I waited some more until finally, one day, in one of these meetings of the Enterprise Software Architecture Committee, ES6 was approved. Well, at that point, I was really interested in having teams opt in without worrying about the plumbing. And we were using Grunt at the time, with lots of duplicated configs across applications. There was already an effort underway to consolidate those configs, so I piggybacked on that. We published an NPM package that teams could install and get ES6 features for free. All good, right? Well, at that time, we were also weaning ourselves off Bower, which was the dominant package manager for the client at the time. And we decided to move to JSPM, which was a noble but failed experiment in polyfilling module loading in the browser. The problem with JSPM is that not only does it want to load modules in the browser, it wants to transpile them there as well, which you might imagine is really slow. But At build time, it uses Node, it uses Babel, and it's fast. So I just offset the transpiling to Grunt, and I have Grunt and Babel for development, and JSPAM and Babel at build time. So now my developers are pumped. Everyone's stoked. We're ready to conquer the world. But there's still one problem, and that is most of them haven't been following the spec like I have. And some of them don't even know that ES6 is a thing. So I put my teaching hat back on, and I gave a condensed version of ES6 in depth for the enterprise. And then I used code reviews as an opportunity to suggest ES6 syntax and features to solve problems that were already on the table. Slowly but surely, it started to sink in until a couple of months later, our first ES6 code was deployed to production. So what's the big deal? Who cares? Well, we're talking about JavaScript. And JavaScript is arguably the most misunderstood language in widespread use. It's also arguably the most important by virtue of its magnitude of deployment alone. It's not just in browsers anymore. It's been for a while now viable on the server. It's a first-class citizen in databases, automation tools, and even operating systems at this point. And it's the undisputed king of the web. And it continues to eat the rest of the world. So let's talk about what's new. What's in ES6? So this was the first major update in the language's history, really since 1995. And you can break down the updates into three broad categories. The first is syntax. So this is new ways of expressing existing behavior that the language already has. We get things like rest, spread, destructuring, block scoping, arrow functions, and modules. The second broad category of updates are enhancements. So these are enhancements to built-ins, or the standard library in JavaScript. So we get some updates to strings and arrays and objects, amongst others. And then the last broad category of updates are entirely new features. And I'm going to argue later that this is where the real meat and potatoes of ES6 lies. These are things like symbols, generators, proxies, and promises. It's big. It's a really large update. Again, this was the first major update in 20 years of the language. Can't possibly cover all of it today, so I'm going to talk about the things that I think are kind of important, starting with syntax. So we get a step forward in what we got in ES5 with the object literal syntax. We get method and property shorthands, computed properties. These are a no-brainer. Most teams have adopted these. We get default arguments that let you provide a default for function arguments. Bear with me. I know most modern programming languages have default arguments already, but JavaScript. We get this nice little ... operator, and this guy has a split personality. Its first personality is rest, which means it gathers the rest of a function's arguments together into a true array and lets you do real array options or operations on this without borrowing from array.prototype. So it lets you do things like manipulate an array and then call a base function, right, with the opposite of the default value, for example. Its second personality is spread, which does the opposite. It spreads out elements in a collection, if you will. Here's an array with the spread operator being used. I haven't actually seen this a lot in production in the last 3 years. But it can also be used to spread out the arguments to a function. So we see that same example before. If you don't need to provide the value of this, it's an alternative to apply, function.apply. OK, let's talk about destructuring, or more concisely, destructuring assignment. This feature was kind of widely criticized while the spec was being worked on, mostly due to examples like this, which don't really give any value and just make the code even more opaque and hard to read. But I think most people would agree that this is a really readable syntax. This is widespread destructuring of the named exports of a module. It's also a common pattern in React to destructure props. And you can actually combine this with default function arguments for a really concise and expressive way to provide sort of a consistent API for functions, if you will. Doug Crockford's really big onto this pattern. Let's talk about block scoping. So up until 2015, we had exactly 2 scopes in JavaScript: global scope and the lexical or function scope. So even though curly brackets like this is a perfectly valid block in ES5, this doesn't do anything. The variable name is hoisted and just gets reassigned. But in ES6, with the let operator, we actually get block scoping. Doesn't look like this would be useful, but this can actually replace the iffy or immediately invoked function expression if you need to do setup without polluting the global scope. The other block scope, right before we move on to that, the other thing this can solve, although I still don't recommend doing this, is the problem you get with creating functions in a loop. This is the classic closure problem. And this is a question that I've given in interviews in the past quite a bit, and people have given me shit about it because it's a contrived example. I'm never going to see code like this in production. But I got vindicated when a problem just like this came up in production, and the dev who found it said, the only reason I recognized it so fast is because it looked like Tim's interview question. For those who don't know, this is basically going to close over the variable I, and every function that gets executed in that array will be the value of 5 at the end, which is 5, or the value of I. So in ES5 or below, the only way to solve this is to force evaluation of that variable during the iteration, either with an IFE or a separate function. In ES6, block scoping will create a new instance of that variable every time. Again, I don't recommend that you do this, but this can solve the problem for you if you find yourself in that position. The other block scoped operator we get is const, which presumably is short for constant. And we would be, I think, reasonable in assuming that a constant can't be mutated, but we'd be wrong, because const is not immutable. Const is only a mutable assignment, not a mutable value. Right? So any of the properties of an object that are not primitive can be mutated. It's more of a signal of intent than actual immutability. Arrow functions are important, not just because they provide a nice, concise syntax. There's some actual use cases for them. Brendan Eich has said that if he could change one thing about JavaScript when it first came out, it would be the function keyword, because it's so verbose. We got various different flavors of them. And in my opinion, they're useful in 3 different use cases. The first is they're really good for terse callbacks. So when you're doing array manipulation or promise chaining, things like that, they really shine, make the code a lot more readable. The second is they retain the value of this from their enclosing lexical scope. So you don't need to do crazy things like var that equals this or function.bind. They're still valid use cases for function.bind. And the third is that it really shines for currying or partial application. This gives you a really terse and readable syntax. But as tempting as it is to use arrow functions everywhere you can use function declaration, there's a reason why function declarations are still around. They are not a golden hammer. First off, they can't be hoisted. Now, this is not as much of an issue now that we have actual block scoping. But if you're introducing this into a legacy code base, it's a foot gun to look out for. And the other thing is they can't be bound. I mentioned function.bind. These are functions. They inherit from function.prototype. This is a perfectly legal operation. It just won't do anything. It won't actually change the value of this. It will always be the value of this from the enclosing lexical scope. Okay, template literals give us a really nice, concise syntax for variable interpolation. We used to do lots of tricks like this in ES5 to tokenize a string just by borrowing join from array and passing your token as the argument to it. Now we get something that actually signifies the intent and is a little easier to read. They also potentially can replace even the simplest of templating libraries. A lot of people don't even realize that Lodash and its predecessor, underscore, actually have a micro-templating engine included. It's the one you use when you don't want to reach for handlebars or mustache or something heavier weight. But with ES6, we can almost entirely drop this. And when you bring in multi-line string support and tagged template functions, which I'm not going to cover here, but basically it gives you a way of parsing the strings and tokens that are passed into a template, you can write your own templating engine natively. And the last thing that they can do is potentially solve this double versus single quotes thing once and for all. If you just put backticks everywhere in your code base, you get rid of that, and you also get character escaping multi-line strings and all that great stuff for free. And last syntax thing I want to talk about is modules. So JavaScript, up until 2015, was basically the only widespread modern programming language with no concept of a module system. Modules are a great best practice. They help us structure our code and have a proper dependency tree. But JavaScript has had no modules in its 20-year history to this point. So the community's been really creative in stepping in to fill this gap with things like object namespacing, the immediately invoked function expression, or a variant of that, which is the JavaScript module pattern. On the server, we got CommonJS, and its brother on the client, the asynchronous module definition, as embodied by require.js. But my personal favorite is script tag vomit. ES6 gives us native modules with all of their glory, right? And it's awesome. Right? There's just one problem, and that is that while the syntax made the cut for the ES6 spec, a loader did not. So we have no way until now, and I'll touch on that later, to load modules in the browser. So again, the community stepped up to the plate and gave us some incredible tools to do this, right? To parse the dependency tree and turn these into something that's consumable by a browser. And some of these do additional things like static analysis and tree shaking. Now, module loading natively has just dropped in most major browsers. You can actually load modules without a polyfill or a bundler, but Traversing in a dependency tree of a large JavaScript application and actually fetching all of those over HTTP is prohibitively expensive. So I think, for the time being, until HTTP 2 and aggressive module caching are rolled out widely across the web, bundling is probably still the future. Okay, we've talked about syntax. Let's talk about some enhancements. So we got a good set of enhancements to the standard library of JavaScript, what we like to refer as built-in objects, starting with strings. String got a handful. Most of these are more about the semantics and the expression of intent than any kind of real syntax saving, although string.ends with gives you both. Array gives us a few additional enhancements, I think the most important of which are find and find index. They let us kind of reduce our dependency on libraries like Lodash and underscore to do that for us. Number got some enhancements, and most of these actually are just moving global functions off the window object into a named module, number. Math got some significant enhancements, and I'm going to just put a disclaimer that while some of you in the room may use these on a regular basis, I don't. And imposter syndrome be damned, I'm not afraid to admit that they're pretty much just Greek to me. All right, object got one functional enhancement, but it's an important one, and that's object.assign. It lets us do mix-ins natively. Super cool, super easy to understand. There are some caveats, though. You want to be careful. First off, it's not immutable. So anything in that target object, in the source object that is not a primitive type will be copied by reference. So just be careful. The other is it won't copy properties that aren't its own. So it won't traverse the dependency tree up the prototype train. If you need that, you need a little extra work on your own. All right, so we've talked about syntax. We've talked about enhancements. All that stuff's great. There's some really good syntax sugar. There's some nice shortcuts, terser code, et cetera. But ultimately, in my opinion, the really important category of updates are the brand new features. This is what I call the good stuff in ES6. Starting with symbols. Symbols are a new primitive type, and their primary purpose is to provide unique, immutable identifiers for well-known methods. And the primary target audience are browser vendors that are implementing built-ins. So in the absence of static typing and interfaces and access modifiers in JavaScript, these provide us a way of predictably defining expected behaviors on objects. Semantics are pretty simple. We call this symbol function. It's actually not a constructor, despite the capital S. We get back this immutable, unique symbol. Here we're using computed syntax on an object, computed property syntax to reference it. And then we get a nice accompanying little reflection method to inspect the symbols on an object. One of the side effects of this, or one of the interesting side cases, aside from its main one, is you can actually achieve true privacy. So here we've got a closure that returns a constructor. And in that closure, we create a new symbol. And then every constructor, every instance created from that constructor gets a truly private property keyed by that symbol. All right, next up is irritables, or maybe iterables. Iterables is a new interface in JavaScript. We don't have interfaces in JavaScript, but it's a contract. And all of the built-in collections, array, strings, which are just collections of characters, and the new data types map and set, they all implement this. So here, for example, is the iterator, or the iterable interface implemented on an array. And you basically just get an iterator back by calling a method keyed by the well-known symbol iterator, and then you call next on it until it's done. Kind of verbose. There's easier ways to consume it, and we actually got a couple of new syntaxes in ES6 to consume this, one of which is for of. For of is like for in on objects, only instead of going over keys, it returns the values. And then the spread operator that we've already seen also will consume any iterable. So here we're going to call the symbol iterator method on a string, get back its iterator, and consume it with the spread operator. It's like string.split with a lot more characters. So you can implement iterables yourself on any object just by implementing a method keyed by symbol iterator and following that interface. You can do it yourself. But it turns out there's a better way, and that is generators. So generators are just functions that can be paused and then later resumed. And they have three main roles. The first role is as producer. Producer of what? Producer of iterables. We can, with a generator function, return an iterable from a function. And since functions can be composed, and iterables give us values one at a time when we ask for them, they let us be lazy. And what I mean by that is that we can compose generator functions to lazily evaluate collections one at a time and gate those such that we never go more than what we're looking for. The second role of generators is as consumers. So in addition to yielding values out, generators can actually take values in. So we can do things like, here's a generic consumer that takes an iterable and some consumer. It starts off the generator and then passes in everything in that iterable to the consumer. This is a contrived example, but there's probably some practical applications that I just haven't gotten to yet. And the last and most important role of generators is as coroutines. So these are functions that both take in and yield values. And probably the most popular implementation of this out in the open source community is Redux Saga. For those who aren't familiar with this, it's a side effect library used to handle asynchronous actions in Redux. And basically, it's middleware that sits in between a dispatch and the Redux store. And these directives that Redux give you, the call, put, et cetera, those just handle resolving promises and feeding the generator with next with the result of the promise. OK, proxies, the metaphor from the web holds up pretty well. Most people are familiar with proxy from a web proxy that sits between you and a web server. And it's actually a pretty good metaphor. It holds up pretty well. And when we talk about proxies in JavaScript, what we're talking about is reflection, or more specifically, reflective metaprogramming. And reflective metaprogramming comes in three flavors. The first is introspection. So introspection is the ability to inspect the structure of a running program. And we've had this since at least ES5 with object.keys, and going back even further to ES3 with object.hasOwnProperty. The second type of reflective metaprogramming is self-modification. And we've had this since at least ES5 with things like object.defineProperty. And then the last type of reflective metaprogramming is inception. We all know that's impossible. It's actually intercession, which is the ability to redefine the semantics of some operations in a running program. This is where it gets really interesting. But what does that mean in JavaScript? Well, one of those would be to potentially intercept a getter and a setter on an object, right? And then redefine how that works. And we've been able to do this in CS5 with object.defineProperty. Here we go through each of the keys on the source object, and then we define a new object that intercepts that, and we can redefine those semantics. So proxies in ES6 give us a slightly terser syntax for the same thing. They're traps, sort of analogous to traps in an operating system. And in this case, it's one size fits all. You do a set, and you get in the target, whatever the prop name is, and potentially a value. And we can do interesting things with this, like validation in this example. Since we can basically obfuscate the internals of the object, we can do some interesting things. We can embody common patterns like the facade pattern. So here, for example, we've got a POJO, a plain old JavaScript object that's wrapping local storage. And you use it just by setting and getting properties, on the object. And I think the applications here are boundless. There's all sorts of great things that you could obfuscate behind a simple POJO. Since functions are also objects, we can actually intercept function calls. So we can use the corresponding reflect API, which I'm not going to talk about a whole lot, but it maps one-to-one with the traps available to our proxy. And so here we can redefine the semantics of a function. This is an alternate and very verbose way of doing partial application of a function. So here's all the traps that you get. Like the one that's really interesting here in my mind is construct. It lets you redefine a constructor. So you can do conditional instantiation of objects. You can do selective data hiding. You can do all sorts of really things, including being paranoid. Because proxies also come in a revocable variant. So you can issue a proxy, and then at some later point, you can revoke access to it. So here, we're going to revoke access whenever anyone tries to write to a private property, keyed with an underscore. And not only is it paranoid, it's rude, because we don't even give an error. We just revoke. All right, last up is promises. ES6 brings us native promises, finally. Well, actually, finally didn't make the cut. It did drop in ES 2018, just last month, the month before. But we do get native promises. They come in a constructor form. We also get some static methods to return a promise immediately or handle concurrent promises. We didn't get the ability either to cancel a promise that's already underway. But on the bright side, you won't ever have any broken promises. But these shortcomings have led to some criticism in the community. And a lot of people still prefer libraries like Q or Bluebird for their promise needs. But I would argue that just like this solved the 80% use case for querying the DOM without needing jQuery, I think this is also probably going to solve the 80% use case for basic promise usage. So all this is amazing, right? But the ES6 spec didn't come without some controversy. There's always people out there that legitimately or not want to complain about new things. The first set of controversy came around syntax. So there's a big part of the surface area in ES6 that's just syntactic sugar. It's just new ways of expressing things we could already do. And we had some people that were in the camp of, I've already learned ES5. Why do I need to learn all this new syntax? It's not giving me anything new. And the other camp was that effort could have better be spent on entirely new features versus just syntax sugar. But never underestimate developer happiness. A lot of developers are coming at JavaScript first through ES6. They like these features, and there's some like me that think they're a great terse expression and a time saver. So if your developers are happy, they're likely to be more engaged, and you should be happy too. And then there's also statistics. There's been quite a few studies showing a relevant correlation between the overall lines of code in the code base and the incidence of defects. So if you can reduce the lines of code by any means, you should see an accompanying decrease in defect incidence. All right, how many people use source maps? Anyone use source maps? Okay, we no longer live in a world where we run the code we write, right? We're typically going through multiple stages of transformation. And along the way, source maps map the symbols that are produced all the way back to your original source, letting you debug the code you wrote as you're troubleshooting. But it's not perfect. This is a game of catch the breakpoint from production code I wrote a few years ago. The experience is vastly superior to console.log. But it's not perfect yet. But by far, the single most controversial single feature in ES6 is classes. And I'm here to tell you definitively, 3 years later, that JavaScript still doesn't have classes. I know if it walks like a duck, talks like a duck, it's not a duck. It's just syntax sugar on top of constructors in the prototype chain. This desugars into this. And this just desugars into this. So there's really polar opposites on this topic. Some people love them, some people hate them. There's not a lot of people in the middle, like me, that are just sort of pragmatists and accept them for what they are. On the pro side, it's a terser syntax. I actually admire the terse syntax. I just wish they could have figured out how to call it something other than classes and bring in that kind of the metaphor from class-based OO. There's a lot of other benefits, but I think the main reason this was done was to make JavaScript more approachable to people coming from class-based OO languages like Java and C#. But there's some serious non-trivial cons as well. And I think the biggest one is that the syntax, this new syntax, is so different from the underlying semantics of prototype chains that it just confuses those same OO devs that came from Java and C#. And this was beautifully illustrated when I gave my in-depth series during the coding portion. One of the guys was a Java dev, and he just stopped and looked at me and was like, that's not how this works. But they're here to stay. I think with major libraries and frameworks like Angular and React disseminating class syntax everywhere, we're stuck with them. So wrapping up, why do I think any of this is important? Well, the main reason I think that this set of updates, particularly the updates to the built-in standard library are important is because they let us go native further than we could before. And by going native, I mean that all things considered, all things being equal, I'm a huge proponent of using a native feature of a language over its equivalent in a library or framework. It makes your code more future-proof. It makes it easier for new devs to understand. And it also reduces potentially your bundle size. And so some of these things that we get with ES6 let us reduce the dependencies we're going to pull into our bundles, deliver less JavaScript, and allow our code to be future-proofed. So how much of ES6 is legit and how much of it is just hype? I don't think a lot of it is hype. And we have to remember that ES6 is decided by a committee. And quite a few of these features were actually originally considered for ES4, work on which began right after the ES3 spec was finalized in 1999. So I think we can safely say that ES6 is legit. What's next? Well, most teams have barely scratched the surface of what you can do. And I'm just as guilty. I think most people haven't gone beyond syntactic sugar. Very few teams have implemented proxies. There's some technical limitations there as well. Generators also haven't been widely used outside of Redux sagas. But I'm a pragmatist. So I don't just glom onto something because it's shiny. There's got to be a tangible reason to use it. So what's next for the language? Should we expect some more earth-shattering, life-changing updates like ES6? Well, probably not, because ES6 was the last major update, the first and last major update the language will ever get. The committee decided to move to yearly incremental releases, hence the name ES 2015, and it seems to be working, because ES 2016 had exactly 2 features. the exponentiation operator, and array prototype. That includes, which left me feeling gypped because I couldn't really give an in-depth talk on ES 2016. ES 2017 was a bit more ambitious. It has features like async and await and a handful of other important features. ES 2018 just dropped in June. It includes promise.finally, finally. It includes object rest spread properties, asynchronous generators, some other important stuff. The other versions are coming yearly. We'll start seeing this thing gradually evolve. And then the real game changer for all of us is WebAssembly. WebAssembly is a bytecode format for the browser that lets other languages transpile directly to the browser. And it lets me say something that I never thought I would say in my 23 years of software development, and that is, if you want to do cool things on the web, learn C. And lastly, I give you ice cream. What does ice cream have to do with ES6? Absolutely nothing. But my 10-year-old daughter asked me to include a slide on ice cream, and you don't say no to that shit. That's all I got.